In the previous tutorials, I explained the architectures based on microservices and containers, as well as the core concepts to use Docker. In this third video, I'm going to explain how to create our Kubernetes cluster in the cloud using the Google Cloud Platform. Specifically, we will create a cluster made of two computers, that is, two nodes. We will first authenticate on the Google website using a Google account. Once authenticated, then we will access to the Google Cloud web page through the address cloud.google.com. Before continuing, it must be clear that Google Cloud services are not free and therefore have an economic cost. Through Google Cloud, we can quickly have a wide range of hardware and software resources on demand. These resources are not cheap and we must be very careful when deciding to use them. Luckily, Google offers an initial credit amount for free that we can freely use to test and learn their platform without spending money. To activate the free credit, we will select the blue button in the upper right corner. Next, we will enter our personal data and finally, we will enter our payment information. This last part is needed because once we have used up all the free credit, then Google will charge us for the services we are using. Therefore, it is important that once we have done our test and we are not interested in continuing to use Google Cloud services, then we will delete our cluster and any other resource or service that we are using. Next, we will access to our Google Cloud console. In the upper navigation bar, we have a selector that contains all our projects. By default, there is already one project created, but we will start by creating a new project where there will be our Kubernetes cluster. We enter a name for the new project and create it. Once created, we select it. If the project does not appear in the upper bar, then reload the web page and it will appear. Before starting to create our cluster, we will give other users access to our project. This is a very common thing if we work as a team during the development of a project, by selecting the IAM option from the IAM and admin section. Our Google username will appear in the list of users. We will add another user by entering his email address in the search bar. In this example, I will assign the role of project editor to the user. From the Google Cloud Console, we have many functionalities and actions that can be done from the web interface. To take advantage of all the potential offered by this platform and learn all the technical concepts, I recommend using the Cloud SDK, which will allow us, among other things, to control all our Google Cloud services from the command line. To install the Cloud SDK, we will first download it from the webpage cloud.google.com/SDK. On this page, we can download the SDK according to the existing platforms. In my case, I will download the 64-bit version for macOS. Once the file is downloaded and unzipped, then we will execute the installation script install.sh. Once the installation finishes, we can start using it. The first step will be to initialize the SDK with the command gcloud init. This command will open the Google Authentication web page. We select the same user that we have used to register to Google Cloud, and we will give permissions to the Cloud SDK so that it can interact with our Google Cloud account. We go back to the terminal and select the project that we have previously created from the Google Cloud console. We can obtain the detailed information of the Google Cloud client that we have installed on our computer with the command gcloud info. This will show us the Google account that we are using, as well as the Google Cloud project that we have selected. To create our Kubernetes cluster, we must first decide and choose the Google CPD where we want to create it. We can view the different Google Cloud CPDs at the web address cloud.google.com/compute/docs/regions-zones. Regions are usually states or countries. Within a region, Google can have different zones, each with its own CPD. It is important to take in consideration the different types of CPUs and technologies available in each region and area. For example, if we want to run a machine learning process in our cluster, then we will surely be interested in choosing an area that has GPUs. In this example, I will choose the zone Europe-West 1-B, located in Belgium and which has machines of the N1 family. Later, I will explain the different types of machines available. We return to the terminal and indicate to Google Cloud that by default we want to work with the Europe-West 1-B zone. To do this, we will use the gcloud commands as follows: gcloud config set compute/zone Europe-West 1-B. The next step will be to install the kubectl command. Kubectl is the tool that we will use to manage our Kubernetes cluster. In order to install this tool, we will run the following command: gcloud components install kubectl. To allow kubectl to interact with the Google Cloud Kubernetes API, we must first enable this API. From the dashboard of the Google Cloud Console, select the link Go to APIs Overview. Now select the button with the text Enable APIs and Services at the top. In the search bar, introduce the word Kubernetes, and then the Kubernetes API will automatically appear in the results list. Select it and finally press the Enable button to activate it. Now we only have to decide the type of machines or nodes that we want for our cluster. We enter the section Types of Machines in the online documentation. Google classifies its machines into families, depending on the type of service or computing that we want to perform. In order to offer web services such as web hosting, APIs, databases, execution of low-intensity processes, and sustained scalability, I recommend the N1 family. For this cluster, I will choose the type N1 Standard 2 that has 2 virtual cores and 7.5 gigabytes of RAM memory. I will create a cluster called AlbiaSoft, which will contain two nodes of type N1 standard 2, and which will be located in the Europe West 1B zone in Belgium. Now, to create a cluster, run the following command: gcloud container clusters create albiasoft dash dash num dash nodes 2 dash dash machine dash type n1 dash standard dash 2 dash dash zone Europe dash West 1 dash B. This process may take a few minutes, so you have to be patient. Once created, it will show a brief summary of the cluster on the screen. To list the nodes of our cluster, we will use the kubectl tool as follows: kubectl get nodes. We can access via SSH within a cluster node. We should never do this, it is not necessary, but I will do it so that you can see the processes that are running inside of these machines. We observe that the CPU of these nodes is a 2.3 GHz Intel Xeon with a physical core, which in practice are two virtual cores. We also know that it has 7.6 million kilobytes of RAM, which in practice is about 7.5 gigabytes. Among the processes running on the machine, we observe that there is a Docker daemon that is in charge of executing Docker containers, and there is also a process called kubelet. This process is part of Kubernetes and is responsible, among other things, for processing the kubectl commands and for orchestrating and monitoring the pods and their containers. As a general rule, you never have to manipulate the nodes. This is the responsibility of Kubernetes. To get detailed information of a node, we will do it with the command kubectl describe node, followed by the name of the node. This can help us to check the status of a node and see, for example, its usage. If we observe that the CPU or memory usage of a node is reaching its limit, then we will have to consider expanding the cluster with an additional node or configuring the microservices to make a more responsible use of resources. We will see this topic in the coming videos. An interesting thing about the nodes is that they have a persistent volume of data, that is, a hard disk. Later, we will see that it's not convenient to use these disks to store data permanently, since the microservices that run in a Kubernetes cluster are highly volatile, and to ensure the persistence of the data, we will need to create additional volumes to store persistent data. Once our cluster is created, we can install additional plugins. I suggest installing the Network Policy plugin, that in the future will allow us to define internal network rules and policies in the cluster, for example, to ensure which microservices can communicate with each other and which ones not. Once the plugin is installed, we will enable it. To finish, we will do a brief review of the Google Cloud Console, where we can see the information of our cluster from a graphic interface. Certainly, some of the operations that can be performed from the command line can also be performed from the graphic interface. Not all, but many yes. I strongly recommend using the command line. It is the fastest and safest way to manage our cluster and the most effective way to learn Kubernetes well. I hope this tutorial was very useful and see you in the next chapter.